Welcome. In this video, we will go through the Composio source code and we will check the implementation of one of the local tools so that it's clear how all these things are implemented and how someone can easily add their own functionalities to Composio to use with all our supported platforms with Composio. So let's start. So this is the Composio registry and you're welcome to visit this. Let's clone this locally and then make our changes. So yeah, we have cloned the repository and this is just a version of the folder structure that was shown in the previous video. In the last video, we saw that we have two relevant folders in the Composer folder. One is the local tool folder and this is the client folder. So first, let's go to the local tools folder and we have a dedicated folder for each of the local tools that we mentioned before. One for files, one for the code explanation, then the local workspace, then the rack tool. And today we are going to see the implementation of the mathematical tool. This is basically the simplest one, but this is the perfect example so that someone who has ideas of their own function or who wants to add something that would enhance the abilities of their own agents will find very easy to do. As we mentioned, each local tool folder will have an action folder that will contain implementation of all the actions, and then it will have a tool file outside where it will implement the whole tool. So you can see there is an action folder and there is a tool file folder. First, let's go to the action folder. Then you can see there is one action and the relevant image file files. So let's go to the action. Everything is commented. I will uncomment and explain on the way. So we first do the relevant imports. This is the action class Composio provides and the base class for all the actions to be implemented. For every action, we expect one request schema and one response schema, both of which are Pydantic based models. In this case, for our calculator tool, we expect only a string that will contain some expression, a very simple format which is this or this. And when these are provided, the tool will execute those and return the result. So this is the request schema. It's having only one parameter, string type, and this is the response schema where we are expecting the result. Expect as a string, but it could be number also. But for our simplicity, we kept it string. And they must have their own description because these descriptions will be provided to the LLM so that it can decide which values to provide for the specific function call. And then when we have the response schema and the request schema, then comes the action implementation. So whenever we have to implement an action that has to be inherited from the provided action class, in each action, we must have a docstring that will be the description of the function schema provided to the agent or the LLM. So this must be provided for your own tool. And then there are some class values. One is the display name. This would be the short summary of the function. So choose this carefully. And we mentioned the response and request schemas we defined before. Then you can add tags, which will help you when you have defined a lot of tools, a lot of actions, and you can group them or filter them by tags. So that's optional. And then here is the tool's name. So I am calling this whole tool mathematical, and one of the action is calculator, or one of the function is calculator, but I plan to add more things. It could be differentiation, integration, could be some other relevant mathematical operations. And then finally, the most important thing, the execute function. When the LLM gives us the function parameters, okay, how to call these functions, the next step is we have to execute that function. This execution generally occurs for the general Composio tools in the Composio server, but here you will write this execute function by your own. And so after you get the relevant parameters, you will decide how to execute this function. That's totally on you. You can execute this through some shell command, some subprocess, or you can execute this just valid Python. So that's on. And finally, we expect an execution detail, which itself is an JSON object that gives us the execution status. It could be the true or false depending on the success. You can see if the operation is valid and we can execute it, we give executed true. Otherwise, we give executed false. And then if we have successfully got it, then we return the response data. In this case, this is only an integer or a string value, but when you define more complex function, the output can be complex JSON objects. This is the whole structure of one action. Like this, you can define as many actions as you want in this action folder. And then when you have defined all of those, you go to the init file and you import as many actions you want the tool to be capable of, you will import it. Next step is you have to implement the tool. So for the action, we had action base class. For the tool, we have a tool base class. So we import the tool base class as well. We import the previously implemented action or actions. Then whenever we define a tool, we must inherit that from the provided tool class and provide some tool description to let others know what this tool is for. And then all the actions you want here to be available, you just return all those actions in this actions. So Composio will internally call this actions class and it will use all the actions that are available from this action members output. And also there is a trigger functionality for Composio, but let's not dive into it now. So next we will go to the init file so that the import is hassleless. We will export it through the init class, the tool we have defined. Once you have defined all the actions you want and the tools you want, the task of this folder is done. The next step is go to the client folder, and as we saw in the previous video, we have tasks in two places. One is registering the local tool we have defined, and another is adding it to the app and action enum. First, we will go to the local handler. Anything or any new tool we have implemented in the local tools, we will import it. Okay, I think there's a typo here. This would, yes. So whatever tool you have implemented, you will import here, and in the register function, you will add that tool. So that's step one. We will register the implemented tool in this register local tool function just by returning it. And the second task is in the enum. We are already familiar in the Composio structure that we use the app and action enum to access all the available tools and their available actions. So we will go to the app class and this. We will give a key for our new tool and a relevant string. This string must be the lowercase version of name of our tool. So tool is mathematical, so it's the lower form version of our tool. And the same thing is for action. In the action, you will find, and what we'll do is we'll come here and you will just add a new key. This might be whatever you want, but we prefer it to be tool name and then the action. And in the tuple, the first thing would be relevant tool name, then the tool name for the action name. In our case, which is the mathematical, the tool name and the calculator, the action name, and finally two tools. These have their own implications, which we won't go that deep into today. And with that, we have all the things necessary to add newer local tools. So let's go through the steps again. We will go to the local tools function, folders and add a new folder. Inside that, we will add an action folder which will contain all the actions implementation. Every action implementation will contain a request schema and a response schema, and finally an action class which will inherit from the provided action base class and will implement an execute function. Then we will import all of this, accumulating all this into the init file, and then we are done with this action folder. Then we'll come to the tool folder. We'll create a tool file where we'll implement the tool. The task of the tool is it must also inherit from the provided tool class, and it must implement an action member that will return all its implemented actions. So that's our preferred structure. And once that is done, we are suggested to import that through the init function. And finally, we will go to the client folder. We have two tasks here. One is registering the local tool, which will be in the local handler and the register function. And another is going to the enum and mentioning all those to the enum so that anyone can access those from any of the frameworks you want. So that's all for this video. This was a longer one, I guess, but ability of implementing a local tool is very important, and you can enhance with as many tools as you want to your agents. So thank you. Let's make something great with Composio.